is Jorge Leon, and I'm here with Auradeep Ghosh and Jai Ramarao. We are Group 2, and we present in this video our semester project, a financial data analysis tool to visualize stock trends. What is financial analysis? Financial analysis consists on studying investment patterns, profitability, and financial trends. The data domain for financial applications usually consists of the following: banking, stock trading, loans, insurance, and real estate. Our focus is on stock trading. The scope of our project has to deal with stock trading analysis. Basically, we do database management based on stock trading, stock profitability based on opening and closing prices of our stocks, and stock trends based on symbol behavior. Let's talk about the application. What we want to do here is take stock information and provide visualization of the prices of a stock symbol over a given date range. Stock analysis can be partitioned into historical and real-time data. We perform our analysis on historical data. This is also part of our scope. Because of this, our focus is targeted more on visualization of stock price movement. Our data was sourced from the website InfoShims, and we chose to work with a data set from the NASDAQ exchange that encompassed information from 1970 to 2010. It included two different daily prices and dividends. The daily prices table was suitable for our scope. Each row on the table contains closing and opening prices on a per-day basis. This is where we get the investment trend information from. Dividends, on the other hand, although it does provide us with stock symbol behavior, the frequency is not the same, and it's a little bit more, doesn't provide as much information, as much data as possible in regards to the stock behavior. So therefore, we did. Besides the NASDAQ dataset, we have other tables which were added to showcase client-based visualization in order to demonstrate the database management part. An advantage of working with another database dataset, is dealing with with complex relations which are linked to each other through certain attributes. We introduced a client table and a client portfolio table. Here, the client table has the names of the clients linked with a global unique identifier, which we'll be discussing later on when we showcase the application.
Hi, this is Auradeep Ghosh, and I'll be picking up on the application design and presentation from where Jorge left off. But before the application presentation, I would do a quick visualization of how the database looks. The database is a SQL Server Express database. Here we can see that we are seeing it using a SQL Server Management Studio, and it is named as Intro to Big Data Project database. Has a few tables: the client table, the client portfolio table, the NASDAQ daily prices table, the NASDAQ dividends table, which is not of any use for our application as of now. The NASDAQ stock symbols table is a reduced table which actually has only the stock symbols from the NASDAQ daily prices list and is used for faster access into the application. The NASDAQ stock trends is actually shown here. It is part of the clustering work that we have done on the data source, and here we can see that the stock symbols are listed as profitable, equitable, and non-profitable. So profitable data sources, stock symbols are those which basically have their average opening daily prices less than their average closing daily prices. Equitable stock symbols are those for which both the averages are same, and the non-profitable ones are those whose average daily starting prices are higher than the average closing daily prices. And before switching on to the application, we'll just showcase the code for a bit in order to see where the joins are. There are three different joins between the client portfolio and the client table, because the client portfolio table actually has a foreign key reference to the global unique identifier column of the client table. So we see that in our application, three different places have their joins. There's one. We head down for the other join here, and finally we have a third join. We'll see the application of these joins in our actual application. Let's head on over to our application. So here we see our actual application design. It has three different parts: the admin panel, the client portfolio panel, and the modify client info panel. The admin panel is more of a administrator segment, where a particular administrator can see the variation of the valuation of different stock symbols over a particular time period. Let us select a few stock symbols for our visualization, and let us see how it varies over a given time period. So we'll select range of time, and for these two stock symbols, the administrator can visualize using a chart control how the variation of prices are over the particular date range. We can actually add different stock symbols on the fly here, and even delete a few if something is not required. So let's see how the visualization goes. And here we can see that the visualization has been created. It actually has the prices of the different stock symbols as listed in this list over a particular date range, which is basically the x-axis, and the valuation is in dollars over the y-axis. So if we would want to delete a particular stock symbol from the visualization, you can easily click it off, probably add a few more, and we can again run the visualization, and the administrator can actually see how the change is made. The client portfolio segment, as we will see next, would basically be a client-centric valuation, just like the administrator mode, but it's more of the stock symbols that a particular client possesses. Let's go and see how it acts. So we can select a particular client, let's say Jorge, and we can see that he has three different stock symbols with different stock volumes. The client stocks tab under here actually visualizes only the daily prices and not the actual valuation in terms of how much investment a client has made. So let's see the visualization, and we can actually make it over a particular date range as well. So once we have our visualization, we'll change the date range. So let's head on over to a different date range, and we'll see that how the valuation actually is over that particular date range for the given client Jorge. So we can see this thing, and in the client valuation tab, we can actually select one of the stock symbols for the particular client, and we can see how the actual investment pattern varies in actual terms of volume and the individual prices. So here we can see how the variation is for that given time range as selected from the datetime controllers. Next, we will head over to the modified client info, which is unlike the first two tabs, which is the admin and the client portfolio, which were only visualization segments. The modified client info is actually the database management part, where we will update the client info, or probably delete a client, or we'll probably add a few clients and see how the changes are made. So let's head on over to an update client info at first, and let's select a particular client. Again, we will select Jorge, and we'll see that there are a few stock symbols and allocated stock volumes for those stock symbols. So if we would add like to add on a few more stock symbols here, and basically select a stock symbol, but while adding, we chose one that is already in the list for that particular client, so the application does not allow us to enter that stock symbol. So basically it's a kind of integrity check so that we do not make mistakes. We'll probably add a new stock symbol, and let's add a volume to it. And we'll see that that stock symbol has been allocated to that particular client. So let's see these database changes in the backend. And we'll see here that under the client table, Jorge, who is already a valuable client as he has more than 2 stock symbols allocated to his name, and once we run execute, we see that Jorge actually has 4 different stock symbols now, unlike the 3 previously. And we actually have 2 different triggers on the client portfolio table, which is this. One is on insert and one is on delete. So on insert, if the client has initially two different stock symbols and one is allocated more, so once we have three different stock symbols on his name. He is upgraded to a valuable client. So this is what the trigger does. And let us see the on delete trigger as well. The on delete trigger does the reverse. So after delete, if the particular client has two or less than two stock symbols allocated to his name, he is no more a valuable client, and his status is set to null. So let's see that in the application. So we'll first, before deleting the stock symbol allocated to Jorge, we'll try to update the volume, and we'll set to 90. Update the volume here. It can be seen in the actual front end application. The same changes are reflected in the backend as well. So initially we can see that Mac had been allocated 9000, but once we run the query again, we can see that the Mac stock symbol for Jorge has been updated to a stock volume of 90. We can delete the stock symbols as well. We'll do that from the front end. And once we delete those stock symbols, we'll delete two and see that how Jorge in the backend, who is initially a valuable client as of now, will change back to a non-valuable client. So we'll delete the stock, probably one more, and we'll first see the changes in the client portfolio table, and we can see that Jorge now has only two entries in his name, and in the actual client table we can see Jorge is no more a valuable client. So the actual changes that had been visualized in the front end have been made in the back end as well. So if we would want to delete Jorge from the actual backend, we can do that from the application as well. So we have a delete client button here, which actually deletes the client from the backend, and we have a cascade on delete on the client table. So if an entry is deleted from the client table, the corresponding entries which have foreign key references in the client portfolio table are deleted as well. So let's see that as well. So we'll delete Jorge, and once we do that, we see that Jorge is no more in the client list, and the corresponding entries in the client portfolio table have been deleted as well. So there's a cascade on delete on the client table. Let's add him back. So for that, we'll do add client info, and here we can create a new client. So we'll create Jorge as a client. So once created, we can see that Jorge has been added onto the client list, which can be seen in the backend. Let's see that. So yes, we can verify that yes, Jorge has been allocated as a client, but he is not a valuable client as of now because he has no stock symbols allocated to his name. We'll add a few. And we can see those changes being made here. So here as well, we have that same constraint check. So once we go into the backend, he is still not a valuable client because he has only two stock symbols allocated to his name. Run execute here, and we can see that yes, he has two symbols allocated to his name here. Once we add one more, he will turn a valuable client. Let's do that. And once we add the third stock symbol into Jorge's name, you can see that he will change into a valuable client. So run execute, and we see Jorge actually has three different entries in the client portfolio table, and in the client table, Jorge has been upgraded to a valuable client. So this is this is a visualization of what the application actually does. We'll actually move on over to the data mining segment, the clustering work that has been done, and that would be demonstrated by Sujay. This is all from my part. Thanks.
Hello, I'm Sujay. I wish to continue the clustering part. I wish to first elaborate on why we are using clustering and not classification. As we know, classification is rather to create a model from the existing data, that is to train the data, create a model, and then use it for further prediction. But then clustering is for rather studying the past trend and predicting the, and getting the output in fixed clusters. So our data is the historical data for which we need to see how the trends were for certain periods. So we use k-means clustering for this. That has been our algorithm, and we have already discussed about the three terms: profitable, equitable, and non-profitable. We see that output data using Veka. So let's begin with Veka. Here's the Veka window. Now we can open the pre-processed file. We are looking for a CSV file. This is a CSV file. So we have these two columns in the pre-processed data. Since we are planning to cluster it, we'll choose the cluster tab. We'll choose the algorithm, which is simple k-means. Start clustering, and we'll visualize the outputs. Though this is the output, we'll choose the right x and y axis. We want the stock symbols in the x-axis, the stock cluster in the y-axis. And since we want to see all the three, these are the three different clusters, we can increase the jitter and see the clustering. So these are the profitable stocks, the equitable ones, and the non-profitable ones. You can actually change these options to see different kinds of visualizations. Here each stock has a color. So this is how we see the desired output using Veka. That's all for the presentation. Thank you.